The thing is, as I said, it's going to be based on the general design criteria and the project management skills which we can apply on doing the lake regeneration or any lake structure as such. Now, sorry. Yeah, the first point, what I would like to highlight here is important points to look out for. Okay, for designing, to start with a design or a construction, there are certain criterias which are based upon. Now, what are those criterias? These are general criterias, what you see on your screen, right? Like site topography, geotechnical investigation results, then functional requirements, available area and restrictions, quality of raw material, and construction methodology. Now, all this we'll be looking at in a broader perspective in the coming slides. Moving on further, we will be actually covering today is more pertaining to the earthen dams and the features with a review as a layman perspective, that which will include the sluice gate, then silt and debris trap, and some STP, wetland, all this. I know I was also attending the session on the previous session. There are a lot of things which is already covered on the wetland, but yes, we are just talking about the construction of the wetland, how it will be done, and basically the general points which we can cover on it, right? So moving on to the first point on the sluice gate. Now, what exactly is a sluice gate? Sluice gate is actually a facility to control water levels and the flow rates of waterways. Okay, they are commonly called as control walls. Okay, they can be used for flow measurement and discharge also. Now, the gate size. Now, there is some photographs which is shown on the screen. This photograph is just an indicative. There will be different designs as such. Now, coming on to the gate sizing. Now, the gate size is based on the discharge. Now, that is decided by the upstream depth, tailwater depth, or design of the weir culverts, calibration of sluice gates for irrigation. Now, when we talk about the gate, okay, what does exactly the gate means? It's, as the name says, sluice gate. So everything depends on the gate. Okay, so obviously when you have a gate, you need a gate operator also, right? So the gate operator should be able to operate the gates with the flood waters approaching. Okay, and all the components of the gates have to be designed properly based on the particular requirement. Now, what is the design criteria for all that? Now, the design criteria includes, first is selection of gate and the operating equipment and associated hardware. The point two is gate, frame, stem, guides, wedges, all this, it has to be fabricated from the materials which will provide a minimum service life of 30 years, if not more. Okay. Now, what exactly does it mean? See, there are issues which we have to deal with, corrosiveness of the sewage that needs to be factored. It is always recommended that the gate manufacturer is always kept in the loop, okay, for types of testing to be performed in order to accurately assess the condition of the sewage. Now, if the sewage is having a very severe corrosive thing, then obviously you have to change the material. Now, what material we can use it? It can be stainless steel. Now, stainless steel material, again, there can be guides or frames or gate. All that has to be changed. You can go for stainless steel. Now, with water quality of the sewage, now we are talking sewage considering, as in the last presentation also it was told that there is inadvertently the sewage is entering, right? So we have to factor that in also. Now, looking that into as a perspective, all the components have to be revisited and looked into, because we are talking about an 30 years span, right? So the next point would be the gate should be capable of withstanding the seating, unseating, and the operation head. A seating and unseating head, that is the difference on the elevation of the closed gate elevation, and that should be used at the during the design. Now, all components should be adequate to withstand the stresses encountering during the installation and the operation. Now there might be deformation. All that has to be taken into consideration, because what we are talking about installation is not only at the time when there is minimum flow, it has to be operational and effective during the maximum flow also, right? You need to handle every aspect of that. Now, the point on the gate, it has to again meet the leakage requirements. Now, leakage requirements, what we are talking is about a component. And when there is a component, there is obviously going to be certain leakages, right? Because obviously what we say, water finds its way, right? So there is leakages that has to be taken care of. Specifications to maintain the leakage under the seating head. Now, it is recommended that each gate be well equipped with adjustable wedges. Okay, now those wedges, there are norms to how to have those wedges. There is all that. We are not getting into that into so much of a detail, but I'm just saying that it is again a point in the design criteria as a consultant who we will be looking upon, right? So that is one of the point where we need to form all this basis on the design criteria. Now, when we talk about a silt trap, now a silt trap is actually a basin, right? That is set up in the upstream of a soakway, and which will kind of prevent the silt, soil, sediment, metal entering your water storage system. Okay, that is actually going to have a trap kind of arrangement. The first one what you see is just an indicative figure. Now I have just given you a typical silt trap drawing there. This has not been designed for any particular thing, but this is the components which gets into, so it's not to scale, right? Now, before entering the drainage system, water in the drainage system is directed to the silt trap. That is the at the inlet side, right? As the silt trap fills with the water, the silt settles in the sump. There would be a kind of depression, whereas the silt would be settling down, and the inward pipe has to take the overflow, right? So regular maintenance has to be carried out. Now, if you are building any silt trap, obviously a maintenance is required. Now, to have maintenance, you need to be having an access point. Now, that access point can be kind of multiple way. You can actually, there are traps which also has a bucket kind of a thing, or for larger silt traps you need to actually have some way to get down and pull the silt out or suck the silt out, right? So this is mostly on the silt trap. Similarly, there would be a garbage trap also, right? Now, garbage trap, these are the traps, they trap the garbages inside, right? Now, they are called as traps because they just trap the water inside, preventing the sewer gases from coming out. Now, several connections are needed for connecting a trap. Now, another thing what we actually look at when we are going to do a garbage trap, there is a pitch. Now, what is a pitch? It is the angle in which the water can flow easily and gradually with help of gravity. So every drain pipe, whether underground or in a wall, must have some pitch, some type of pitch, and sloped properly to allow the wastewater to drain out. You can see there is a lot of garbage trapped in the thing. So there has to be a gravitational flow, and it would happen in the same way, right? Uh, okay. Yes. Uh, Coming on to the next point is about the STP. Now, STP is, it is very evident that we can easily say that without an STP, urban lakes, especially we will call it as urban lakes, will not survive. Okay, so you need the sewage to be stopped at the start itself. As obviously, if you can handle it at the source, it is well and good, but at least it has to be handled before entering it. Now, for doing that, the component which is there is the STP. Now, there is an design criteria for the STP also, right? We'll just look into that, how we can design the capacity and the configuration to suit the lake. Now, design criteria for STP depends on certain things. First would be the location of drinking water sources, surface water intakes, groundwater wells, adequacy of isolation from residential area and land use surrounding plant, prevailing wind conditions, susceptibility of the site of flooding, now susceptibility of soil conditions, adequacy of site for future expansion. Now, this is a major thing what we need to look at, because most of the times what we undersize the STP, then again you need to expand it, then obviously you need to have some more space doing that, right? So it has to be always looked into in a broader perspective on the adequacy of the site to cater for future expansion. Then suitability of site with respect to access to receiving body of water or any other treated sewage effluent disposal. Okay, so these points are the basis when we can size the STP and say that yes, we will be able to locate the STP based on the based on the topography or any other parameters what we look into. Now, looking at all this, there is one more point which we can actually get into a detail of it, is on the material selection. Okay, we are only talking about the sizing here. If we had to also revisit or look into the material selection. Now there might be materials, it is kind of the pipes which are getting used in the sewage treatment plants, that all that has to be looked into. Now those factors will be likelihood of blockage and the size of the line required. Then uh, when we are talking about gravitational flow, it has to be having a scoring velocity, right? So minimize solid deposition and grease buildup. Then nature of material to be conveyed and suitable piping materials for application. Now flow characteristics of materials or the head requirements of the pumps. I mean to say that differential head required for gravitational flow, and there would be many other components, right? Then the most important thing also would be looked into is the repair part of it. Now, how do we plan for the repair of such STP in case there is any requirement of any kind of sorry, I'm getting some questions. Yeah, we'll take all these questions at the end, right? So yeah. Yeah, coming back to that. So, need for future repair, that is one more point which we need to look into. And need for future removal of pipe sections. Now, what is installed is not permanent, right? So, that again has to be revisited, and as and when it is required, you need to replace it. So, that is a very important thing which needs to be done. Now, all this, when we talk about STP is not one single process, right? It is an accumulation, or it's a combination of multiple processes. Now, when we talk about design criteria, this is a general design criteria what we tell. Now, there would be specific component designed for a specific process. I'll show you some of the thing. Yeah, one second. Yeah. So based on specific areas, we can term these are the design basis. Now, for example, as let us say sewage pumping station, the design basis would be designed for peak instantaneous flow. For screening also, it's the same thing. For grit removal, designed for peak hourly flow. Okay. Similarly, for primary sedimentation, aeration, then secondary sedimentation. So all this, these are the design basis. For sludge treatment, you have to consider as a basis as maximum monthly mass loading and the flow rates. So when we talk about all this, we would be collecting more information on the surrounding and how it will be done, right? So again, as I in the first slide we saw, all those design parameters will influence the design basis also. If you are having a restriction on the sizing or the topography or the site location, whatever it may be, so it has to be going into the process wise, you get into this minimum requirements on the design. Yeah, moving forward, now we will visit on the wetland. Now, getting into the wetland, a wetland is an ecosystem that is flooded by water either permanently or seasonally. It's a physical barrier that holds water, right? So, wetland, we can term it as saturated, water zone, which can be done. Now, when we talk about that, right? So the primary factor that distinguishes wetlands from other landforms is the characteristic vegetation of aquatic plants adapted to the unique soil, right? So when we get into that, again, we have already understood what exactly the wetland is and how the aquatic plants would be helping into more in the last session. So that is actually I'm skipping a lot of things now, which is already covered now. So again, by such processes, the chemicals can be considerably removed or settled, and clear water can be drawn, right? So the chemicals, what are the chemicals? It might be nitrogen, ammonia, phosphorus, pathogens, many things, right? So when we talk about a wetland, there are two types of wetlands, right? One is a natural wetland, then other is a constructed wetland. Now, what is a natural wetland is as he told it earlier, that there is it's based on the natural habitat. Constructed, again, we can bifurcate that into these types, right? Constructed wetland will have a subsurface flow and a surface flow. Subsurface will have vertical and horizontal. I'm not getting into too much of a detail, but I can just give you uh, because wetland, again, the basis of the design, it's not very much specific. It has to be customized for each lake or for each requirement as such. The sizing and all, as earlier said, it can be bigger than the lake also, right? So when we talk about constructed wetlands, they are artificial wastewater treatment systems. Okay, it might consist of shallow ponds or channels, right? They rely upon natural microbial, biological, physical, and chemical processes to treat wastewater. So they are typically having impervious clay or synthetic liners, right? And engineered structures to control the flow direction, as well as the liquid detention time and the water level, right? So I'll just share with you on the parameters of the wetland which we look into, right? So there is an IS.
I think he has lost connection.
Hello, hello.
Yes, please go ahead.
Yeah, yeah. 1 second. Is the screen shared?
Not yet.
Not yet, yeah.
Okay, 1 second.
Well, Anita Dilas.
Yeah, yeah.
Yes, it is back.
राजू कसं म्हणलं ना बाबा
Can we start?
बाबा मग एक कॉल कर
All others, please unmute yourself.
Yeah. So I was talking on the parameters for testing, right? So wetland, when we test, these are the parameters what we look into, right? So moving forward, we will be talking on 1 second. I guess this is, yeah. So wetland management will cover what does wetland management actually means. You know, you need to have an intensive monitoring, interaction, and cooperation among various agencies involved, maintain important natural processes that cooperate on lakes and may be altered by human activities, conduct regular water quality monitoring. The frequency we have just understood that it can be fortnightly also, right? So creating buffer zone for lake protection, then development of water quality database, and doing all this has to be actually analyzed and discussed and formulated in a way how we can move ahead and how best we can adapt to the requirement for the lake, right? So this is about the wetland. Now we will move on to structures, earthen dams. Actually, I will cover the causes of failure of earthen dams, right? So main causes of earthen dam failure that can be classified into three portions. That would be first would be hydraulic failures, next is seepage failures, and third is structural failures. Hydraulic failures is overtopping, then wave action, toe erosion, gullying. Right. When you talk about seepage failures, is piping and clogging. Structural failures is upstream and downstream slope failures due to formation of excessive pore pressure, and upstream failure due to sudden drawdown by reservoir level or foundation slide, failure due to earthquake, failure due to unprotected side slope, failure due to damage by burrowing animals, and failure due to damage by water soluble materials. Now, this represents whatever we just saw earlier. The first one is the dam failure by overtopping, right? So this comes under hydraulic failures. Now, hydraulic failure is this, right? So when we talk about piping, this is the piping action. You have the Purvis foundation here, you have the lake side, that is the water side being here, but then there would be flow of water and it will erode, have an erosive material, and then you have the piping action here. This can also happen at the bund level, either in the foundation or in the bund level also. Now, when we talk about that, this too would be termed under hydraulic and the seepage failures. All this, what you see down, is structural failures. Okay, you have a weak or soft foundation. There would be maximum times what happens is when you try to build a bund, you will not take care of the foundation. You will not remove the soft soil which is underneath. Now, in case if it is not done, what happens is obviously there is going to be a settlement, because you are going to have a bund which is going to be much heavier load which is going to come, because earlier there was no load. It was maintaining its position. Now when there is a load, the soil weak foundation which is already submerged a longer time, then it may try to yield. Then once that is done, if there is a second type of failure which we are looking at, is the sudden drop down on the water level. So that may happen due to the failure. This is the failure of the bund itself, or it can also happen on the other side, right? So these are all the structural failures. Now, when we talk about failures, then obviously we look upon what can be done, or what is the code mentioning, how it can be done. Now, based on the height of the bund and all, there is a code which also specifies what is to be the width, how it can be protected, or there can be any other measures which can be done as such, right? So this is an dam section showing seepage control features. This is as per IS 9429. Now you can see there is a riprap, it is recommended. Now this has to be again designed. There will be a berm. Okay, now there can be a cutoff drain also. So there is an height which is mentioned for the water level. Then you have a maximum water level above which what riprap can be taken. All that is there. You have to just follow this, right? So when you are constructing a bund, the basic thing is follow the IS codes. And in case there can be any design modifications can be done, yes, the consultant is there to advise you on that, right? Now this also can give you much more in detail thing. When we talk about the placement of the rock and the toe drainage system, okay, this is the riprap, and then how the toe would be done. We are talking about a much bigger bunds or something. A smaller bund can, we can do away with this with only a riprap turfing, only with the bottom stone, right? Yeah, okay. Now when we talk about a dam section, right? Excuse me. Yeah, can continue. Yeah, okay. So this is all as per the IS standards. What is already mentioned as per IS standards, we just have to read it, follow it, right? Now, when we talk about the earthen pond, right? So the main thing would come is the filler material. Now, what is the filler material? How we can use it? Whether what is existing is better, or should we get a new one? All this, again, IS is the Bible. You go with the IS. There is a very specific, detailed mention given in the IS, right? So, design criteria for filter material. The filter material used for drainage system should be classified following criteria. First, it should be more porous than the base material. Then the particle of the base material should not clog the voids of the filter material, and the percentages of the particles finer than 75 micron. The base soil are graded. Okay, so these are the categories. Now, category 1, it has to be greater than 85. 2, these are the categories, and how much it is as per IS, what is the filter media. Based on that, you have the categories also, right? So there is proportions which is already mentioned. So based on the height of the bund, based on the width, based on how you want the bund to be functioned, based on all this, the design criteria can be changed, and it can be visited as required. So similarly is on the weirs, right? What is a weir? Weir is a low head dam. It's a barrier across the width of the river that alters the flow characteristic of the water, right? Usually results in the change of height. Okay, this is provided if you want to have an outlet or an control measure, right? Outlets of the lake, ponds, reservoirs, that way. Now, again, when we talk about weirs, we have to know about the common causes for failure also, right? Excessive and progressive downstream erosion, both within stream and lateral erosion of the banks, erosions of inadequately protected abutments, hydraulic removal of fines and other support material from downstream protection, then deterioration of the cutoff and subsequent loss of containment, and additional aspects specific to concrete, rock fill, or steel structures, right? So all this failures we saw, how the piping action, there is a piping action, then there is erosion. All this can again have remedies. Now, we have the main causes and the remedies. Remedies are, you have a piping action which is happening. So to avoid that, you decrease the hydraulic gradient and increase the path of percolation by providing sufficient length of impervious flow, providing curtains or piles upstream and downstream. Now, rupture of floor due to uplift, we saw the piping action happening, right? So for that, you can provide impervious floor of sufficient length of appropriate thickness. Now, again, appropriate thickness, we have to design it based on the upstream pressure, how much it comes, the uplift pressure, right? Then the third is a rupture of the floor due to suction caused by standing waves. Again, we go with the additional thickness. So most of the things would be addressed if you are considering the floor thickness as one concrete mass, and you design the floor as per that, right? Now, there is 4 on the upstream and the downstream weir, the piles at greater depth at store level, launching aprons, all this are the remedies, right? If we are able to achieve all this, then there would be a lot of things which can be avoided. Now, going back, this section is an Bible where we have to keep on falling back how it will be done based on the height. Now, there are IS codes, we have to maintain all this, right? Now, when we are going to talk about the doing or execution of all this, right? We need to have the exact way of execution. Now, how it would be executed, how it would be monitored, what is the requirement to look into how the contractor will execute it. All this will come into a shell called as project management, right? Now, that project management, we will look into how what we actually do Hello.
Hello. Yeah.
Hello. Yeah. I guess there is a problem with the net.
Okay.
1 second. Let me.
Please share the screen. Yeah.
Yeah, I'll share the screen. I'll join from my phone. Yeah. Yeah. Am I audible?
Yes, of course.
Yeah. So, actually, that's why I switched off the video. There is some problem with the net. Okay. Is the screen visible?
Yes. Now we can see.
Yes. Okay. Now, when we talk about management, okay, let's as it's always said, let's look into the other way, right? So, what happens if there is no proper management? Now, what is management? It's planning, monitoring, controlling quality and safety. Now, let's say if there is no management, what happens? Now, yeah, the likely outcomes would be during construction, or we would say during design and construction, both missing the deadlines, cost overruns, poor quality, loss of reputation for the organization, unsatisfied stakeholders, failure in achieving the objectives for which the project was undertaken, and unsafe conditions. Right. So this is the most likely outcomes which might be occurred. Now, when you are not going to have a proper management or a guiding authority or a person who can let you know how it has to be done and what is the sequence, you will face all these issues, maybe something more also, right? So for doing that, we should understand first what are the project parameters which actually we look into. The project parameters will include scope, quality, effort, risk, and time. Now, for a successful project integration, scope is very important, right? List of goals, objectives, and activities to complete a project. Now, what does exactly scope means? You have to be very clear on what you are going to execute, on what has to be done as an end result. Now, if that keeps on changing, that's kind of you're changing your goalpost time and now, right? So it would be very much essential and very much required that the scope is very clearly defined. Automatically, when you define the scope, the dependent thing on the quality, meeting stakeholders' requirement, the quality of the requirement. Right now, the requirement is for, it might be for design, it might be for execution, or it might be for anything as such, for commitment. You already have specifications that will term as quality. Now you have to be very much clear on the scope. Based on the scope, you derive quality. Your efforts are there to work for the resources to deliver the project goals, and risk has to be looked into, and obviously the time required for the deriving the results. Now all this is connected. One parameter of this is going haywire, then it will affect everything. Actually, if there is a change in scope, obviously the quality is affected. If there is a change in your timelines, then your there might be a cost difference as such. Something would be affected. So mostly what we can hold on is the time. We have to hold on to that. Now, to hold on to the time, we should be very much clear on how we plan the entire thing. Right. Now, planning is one of the most important thing in any project. Like, it might be, in your day-to-day life also. Unless you have a specific plan in place, you will not be able to execute that in the desired fashion or to get the correct results. Now, what does planning actually means? There are different forms of planning. We can bifurcate that or classify it into three. One is project planning, second is project scheduling, and project controlling. Now, when we talk about what is project planning, it is a very initial stage, right? The initial stage, you have to set goals, define the project, then tying the needs of timed project activities and organizing the team. We are in a very, very initial stage. When you start the project, you don't know what would be the next phase, how it will be done. So it is required to plan. So that time, what you are doing is budget, your engineering diagram, cash flow charts, and some material availability details. These are all called as estimates. Then you move on to the next phase called as project scheduling. This is when it would be spanning in the earlier stage of planning, as well as during the execution also. So tying resources to specific activities. Now, relating activities to each other and updating and revising on regular basis. That's what I said. It has to be, this will span in the planning and as well as in the next phase. Now, in this, what you prepared earlier as estimate, that will be translated into a much more filtered version of Gantt chart, milestone chart, or cash flow schedules. Now, all this will start fine tuning your outputs. These are all considering that the, again, going back to the same parameters, scope, quality, everything has been finalized, right? That is what will come into the planning. Scheduling, the next phase. You get into, you are moving ahead with one step ahead, you are climbing it. Then comes the project controlling. The project controlling actually means when you are doing your execution. That time, your outputs, what is desired is budget and any delayed activities, all that. So controlling will, what it mean, monitoring the resources, cost, quality, and budget, right? Revising and changing plans, shifting resources to demand as per the demands. Now, project controlling will come into picture when your planning is in place and scheduling, which you have done a fine tuning. You are coming to a stage where you know what has to be done, and that you are in coming in a phase of execution. It has to be executed. So while execution, you need to monitor it also. Now, all this forms whatever you say. If it is, generalized, when we say project planning, actually it means the bifurcation of these three. That we need to be very clear of. Project planning means not only planning; it also means scheduling and controlling also. Planning is a very initial stage. Move on to scheduling, then you control it, right? Now, for doing all this, there are certain ways to do it. Now, how do we do it? There is a process. Now, that process is formalized by asking these questions. You ask, you want to do any task, you can ask these questions. Now, for what, for how much, and by when? The output of this question would definitely mean that you're defining the project objectives, project scope, and system requirements. This will specify the project deliverables, end items, and the results, as well as the time, cost, and the performance targets, right? The scope and the requirements include criteria the customer will use to determine the acceptability of deliverables at the project completion, right? So this question would give you this kind of information. When you ask how, then it will come into a picture saying define the specific work activities, tasks, or jobs to be done, right? Now, this activities will necessarily be created and delivered for promised deliverables. So again, you are moving into the next phase. You understood for what and for how much. Then you are going to do it, how it would be executed. And then who is going to execute it. This will call for an organization or an individual to come and execute that for planning, right? Then when, in what order, you are setting a sequence. How much and by when, again, that is, we are talking about, are you getting the thing that by how much and when means we will be looking into preparing a budget or a resource plan that allocates the funding, all that, right? How well is you are going to prepare a plan to review and control performance. Now, 1 to 6 is the questions which you go on asking till the time you are executing it. But again, it is not that everything falls in line how it has to be done, right? So you need to repeat certain things if there is a change. Now there would be sometimes when you move on to the project, you come to know that no, this is what has to be done earlier. This was it. Now that is not we will be doing it. So again, you need to revisit and understand how much, when, how well, all this. So again, we are getting into the estimate part, right? So understanding more on planning, uh, you do all this, but it has to be again displayed. Now, there are two techniques. Okay, one is called as a display technique, other is called as an analyzing technique. Now, these two techniques are used together to get the best results. We'll just see what are those techniques. Displaying techniques is milestone chart or a Gantt chart or a task list or network diagram or a 2D task list. Analysis techniques is again, these are based on the display techniques. Critical path, critical chain, PERT, resource leveling, and schedule escalation. Now, if you see, these are the outputs. Okay. The first one, this is a milestone. Obviously, when you do a project, you understand you are going to achieve this milestones, right? So this is called as a milestone. This is just nothing but a number line, right? You have week 1 you will do this, week 2 you will do this, but for example, let's say desilting the lake. The desilting is going to be done in next 1 month, so that's a milestone. Then you start the bund construction. That's again, completion of the bund is one more milestone. That way you have to have your preset milestones, and that would be reviewed. When you get into I'll go with this second one. 4 and 2 is actually a 2D and a 3D task list. Now 2D is nothing but it is just a task and assigned to, right? So 3D will be again having a priority in it, how it will be done. So planning methods are different. These are all displaying techniques where you will understand more into and getting into more into planning. You can analyze this also. Now, network diagram is for analysis. As we saw this, we have critical chain, PERT, resource leveling. All this will happen based on all this techniques only, right? This is a simple Gantt chart, the 3-1. Gantt chart is you have the activities, you have the blue line is the earlier plan, and the red line is what has been executed, actual, and the based on baseline and the actual. Okay, so these are the methods which will be used for planning. Now, when we move on to next topic on the quality, now what does we require? What do we require to improve quality? First is every employee should be made responsible for the quality, because it's a commitment and a teamwork, right? There has to be a quality management program implemented by an authority. The process has to be improved. Okay, and it has to be definite. It has to be definite, it has to be defined, so that the end result is obviously targeted and known to you what you are executing it, or it can't be done in a blind way, right? So in case as you move further, you are finding any issues, it has to be fine tuned. You need to identify and eliminate the problems in the process then and there. Now, for all this, as we say quality, you need to have a quality management system. Now, when you have a quality management system, you'll have, these are the benefits, right? So you have greater efficiency, rework is reduced, there is self-satisfaction, and individual can expect high morale and improved working environment. Then there would be increased profitability, reduce potential claims and warranty callbacks, then reduce the cost of insurance, create an atmosphere of high performance team. So all this is an typical or a general note on the benefits of the quality management. Now, with all this, as I said, you need to have a process for maintaining or inducing the quality in it. There are ways to do it. You have to first have a plan for the quality, then you have to manage and give an assurance. Okay, and then it is on the control. Again, the same way how the planning also happens: planning, executing, monitoring, and controlling. Right. So I'll not get into the detail of this, and I'll just move further on this now. Yeah. Coming on to contract. Okay, this is again one more important point which actually needs to be looked into. If the contract is not managed efficiently or the risk are not managed effectively, what we are going to overshoot is the project budget, poor quality, obviously. Then there would be delays, safety issues, dispute, loss of reputations, poor relations, right? So again, when you are managing the time, when you are managing the quality, similarly, you need to have a contract management also. Now, in that contract management, what needs to be done is client requirement and roles to be decided. Then value engineering, pre-contract and pre-contract cost planning and management, life cycle costing, building elements, construction planning and procurement, your contract administration, then management of risk, evaluations of interim certificates and extension of time. See, these are all aspects which will be covered under contract, and it is required that everyone is having a contract and a definite timeline for execution, right? So that is where all these parameters comes into picture when we are talking about contract, because contract is cost. Cost means obviously it is money which is, if there is time which you are losing, it also costs. If there is a delay, it also costs. Only thing is, if there is a rework, again it costs. So everything has to be managed within those limited parameters. So we will be more concentrating on executing the job the right in the first way. Right now, when we talk about execution, the first thing what comes in mind is safety. Right, safety. Obviously, with such a pandemic around now, we have to be more safe. Right, so getting to zero, it is, safety is not a priority, it is a precondition. Right, you have to consider safety in every aspect during execution. That is much more needed, and it can't be neglected. Right, so I'm taking this topic just to touch upon the requirement as such on the safety part of it. What is safety? Safety means, we say, absence of danger. Right, now for doing that, you need to first eliminate the hazards at the work that creates danger. Okay, there is a risk. Right, so that risk has to be eliminated. Okay, now accidents are caused, they don't happen. Safety must be built in our day-to-day life. Everyone is responsible for safety. Okay, and everyone is held accountable also. Right, no person to be allowed to the work site without any safety or unsafe conditions. Okay, and the most important thing is, client is all the more responsible to initiate and maintain the safety and the health programs, and that complies with the local regulations. Now, we don't have to really say about how the construction people are actually at sites and looking into the accidents and a lot of things which are happening currently. We have to be in a very very conservative mode on safety, that we can't neglect that. Right, so each individual employee has to be made responsible, and it has to be very clearly specified to the contractor, whoever is executing, and the client also equally responsible for that the safety is not neglected. All the health programs, the documents, everything has to be in place. Now, before the start of the work, an accident prevention plan has to be in place. And with this, obviously, there would be a lot of things which are first aid and all that. The training has to be given. These are all minimum requirements of the safety, and it is better that, when there is a communication done with the employees, it is done in the local language. Because while seeing, we are seeing that people come there and have their say on the safety, but then most of things are not followed because of the communication, how it is done. It has not been followed by the employees or maybe the laborers, anyone. So it is very much clear that the communication has to be clear on the safety aspect, and please don't neglect that. Now, all this, looking into all this, will actually cover for a very much required thing, as the quality or the qualities of the engineer. Right, the engineer who is going to be at site, has to look into all this. So coming to with the entire presentation coming to an end now, what I will say is we will be more concentrating on the person who is responsible at site. Now, if we can summarize a quality is of a good engineer, is first is he should have interest to work, he has to take initiatives, understand to work in a group, committed and dedicated, quality and safety conscious. He should be technically sound. Then information has to be shared in a proper way. He has to maintain good health. He has to be technically sound and punctual. And I feel, there are many engineers who lack common sense. Many of you must have come across that. Actually, this is not you'll not get it in any books as such, but this is a very common thing which is there, right? So the person who is going to do it has to be having common sense and understanding how the execution can be done, in what way, what is the sequence, and how it will be executed in a better way, right? So coming on to this slide, talking on the processes of that person who, or the agency who can handle all this, being kind of estimating and contract administration, then contract documents, engineering survey, construction and cost control, form of design, concrete technology, strength of material, and construction management. So these are all parameters which are going to make that person, or the parameters on which any project will be executed in a better way and a neatly documented way, in a technical way, right? I hope we have covered most of things on the project management side also, and as well as some important things on the lake thing also.